Okay, if you're ready, you can go off mute and I will start the webcast.
Great, yes, I am.
All right, starting now.
Okay. Hello, good morning, everyone. This is Mira again. I gave you the first session. Okay, so in the previous two sessions, we built the foundation of chatbots thinking. In session one, we explored what gives a chatbot its identity, from the simple rule-based systems that follow strict patterns to the advanced generative models. The generative models can hold. I figured that. Okay. Okay. So yeah, and in session two, my colleague started with she broke what makes a chatbot's responses good, and then identified four pillars of quality: the accuracy, fluency, relevance, and user satisfaction. These became our tools for deciding and improving chatbot interactions, our lens, and our scalable. But here's the catch. Everything we've done so far has been under controlled condition, almost like running tests in a lab. We assumed one shared language, one shared culture, and one shared way of understanding meaning. In the real world, things aren't that simple. They aren't the same. So a chatbot that performs flawlessly in English might stumble in other languages like Arabic or Japanese. Also, the jokes. A joke that lands well in the United States might fall flat or even offended or offend in other culture. So, for example, when a global brand launched an English chatbot in Latin America, it struggled to connect because it couldn't grasp local slang or cultural notes. That's the illusion we are going to confront today. The idea that AI can operate in a single universal language without context. So, it's time to step out of that lab. Okay. Not yet. Okay. So we have to face the real world, a word that is anything but simple. It's different. There are thousands of languages, dialects, and culture blend. They overlap and sometimes they collide. The idea of building a truly global chatbot, a system that can speak with anyone, anywhere, is an exciting one. For companies with international ambitions, it feels like the ultimate goal. But turning that vision into reality is not that simple. The challenges run much deeper than translating text from one language to another, because language isn't just vocabulary. It combines the culture and the history, might be emotions. They are all what makes someone can make a conversation with another person. The way okay. Or Arabic. Even a simple yes does mean the same in other languages. I hope everything is correct. I'm not sure. Is everything correct? Are you able to hear me?
Yes, you're all good, Mira.
Okay. Thank you, thank you. Okay, thank you, everyone. Yeah, so yeah, we were at if someone said yes in a language doesn't mean the same thing in other language. For example, in Japan, a polite yes might mean I hear you. It doesn't always mean I agree. For example, also voice assistants like Alexa or Siri, they perform well in English-speaking regions, but they often stumble in less resourced languages. For example, someone who's speaking Nigerian or rural Hindi might find that system simply doesn't understand their language or the way they're speaking with. That's not just a technical issue, it's a reflection of the digital divide, where some languages are data rich and others are nearly invisible to AI systems. It's all about the data. If the model was trained on rich data, it could answer anything or it could act almost like a human. But if the data isn't that enough or rich, it will fall apart or might not understand well what someone is talking about. So every assumption we have made about how language works is now being tested. When we move from our controlled environment in that lab into the chaotic global reality, we realize that language isn't a single universal code. It's a living, shifting ecosystem that AI must learn to navigate carefully and respectfully into each different culture background. Okay, so in this session, we're going to go beyond the surface. Instead of looking at global chatbot, okay, yeah, sorry for that. Okay, so yeah, we were saying in this session, we will go beyond and we will look at the global chatbot challenges in broad strokes. We will take them apart piece by piece, examining their linguistics roots and computational complexities, and the ripple effect that they have on how we measure quality. We will explore how accuracy behaves differently across languages. For example, achieving precision in a agglutinative language like Turkish, where words can stretch and merge with complex suffixes, is a completely different task from handling a simpler and more analytic language like English. Also, we will look into the fluency, relevance, and user satisfaction. The fluency, well, let's say a chatbot can generate sentence that is grammatically flawless, yet still sound tone deaf or even disrespectful. It might ignore cultural nods. Imagine a chatbot that says, "Good job" to a senior executive in Japan. It's grammatically fine, but socially off-key because they have this respectful ladder, let's say, for each person in command as seniority. Also, relevance. True relevance goes beyond just staying on topic. It requires cultural awareness and empathy. A response that makes sense linguistically can still miss the mark if it fails to align local customs or humor or social norms. Finally, we will examine user satisfaction. There are metrics like CSAT, which is a short for customer satisfaction score. some metrics like these look objective, but they can easily be misleading if we don't adjust them to cultural context. What I mean here is what counts as satisfied customer in Germany might not mean the same thing in Brazil or other countries, because there are different cultures, different point of views for each country. Also, yeah. So by the end of this deep dive, you will see how each of these pillars, the accuracy, fluency, and relevance, user satisfaction, they shift and blend in the way of linguistics and cultural diversity. Okay, so why is this paramount? We're still here. Okay, so I'm going to explain how much important is this session. It is crucial because it helps us confront the real limits of today's AI systems and appreciate what it truly takes to build fair and inclusive, aware chatbots. It's not just about better algorithms and larger data sets. It's about understanding how our design choices shape human experiences across different languages and cultures. This is also a call for critical thinking. Every decision we make in AI, from how we collect the data to how we evaluate performance, can either empower or exclude entire linguistic communities. So recognizing that is a real impact on a step forward toward responsible innovation. So think of this session as an intellectual journey. We will travel from the fine structure of a single sentence to the broader social norms. It's rather less technical this time. So we will go through what makes a robot or a chatbot respond respectfully and in the best way possible for each culture and community. Yeah, and by the end, you will not only see where current AI systems fall short, but also gain a deeper appreciation for what it takes to make them genuinely global and humanized. Okay, so let's go for the typological challenges of this. So every language has its own unique fingerprint, right? It has its own grammar, structure, rhythm. This is what linguistics call typology, and it varies dramatically from one language to another. Most AI models are still largely Anglo-centric, meaning they are trained primarily on English or languages that resemble English. So when these models encounter languages that play by completely different rules, things start to break down. Well, so for example, English depends heavily on word order to convey meaning. So for example, the dog chased the cat is very different from the cat chased the dog. That's just logic. But in languages like Turkish or Finnish, meaning is carried through word endings, not the order. Okay, is my connection well now? Can you hear me well? Okay, thank you. Great. Okay. So we were, so we were saying languages, about the data. If the data that this model, this specific model was trained on was mostly in English, and that is the main thing these days, because most of the companies that train models, AI models, are located in the US. So mostly the data they have are English spoken data. So if this data was mostly in English, the model will struggle to adapt for other languages like Turkish, Finnish, and language specifically that doesn't have the same order as English. So it will lead to errors in accuracy and fluency when they generate text in those languages. These typological gaps remind us that building multilingual AI isn't just about translation. It's not just getting this word and transform it into its equivalent in the other language. It's deeper than that. It's about teaching machines how to think, just like a human, to think differently in each language. Okay, so let's start with the word order. The word order conundrum. Well, we have in linguistics, we have different types of word order. There is SO, SVO, SOV, VSO. Theoretically speaking, linguistics often classify languages based on the order of the three key elements in the sentence: the subject, the verb, and the object. This small detail completely shapes how a language works. So in SVO, subject, verb, object, it is used about 42% of the world languages, including English, Chinese, and Russian. For example, the user clicks the button. The user is the subject, clicks is the verb, the button is an object. As I told you, this is not a technical session. It's more about talking about the culture and the language or the linguistics. This is actually, we could say that this is an introduction for NLP, which is part of AI, and a huge part of large language models that shapes the chatbot, like ChatGPT and etc. Okay, so the second one is SOV, the subject, object, verb, and verb. Most common order globally, it is found in 45 of languages such as Japanese, Korean, Turkish, and Hindi. So for example, it won't be the user clicks the button. It will be, so it will be the user button clicks. It will change its order. And for the VSO, verb, subject, object, it appears in 9% of languages, including standard Arabic, Irish, and Welsh. So for example, I'm gonna say a sentence in Arabic. So المستخدم which translate in clicking user button. So it shapes differently in Arabic. It doesn't have the same order. So these three types are the main types. There are other types like VOS, OVS, or OSV, but they are rare. Okay. So let's look at how these differences in word order actually affects AI performance. First, the collapse of relation extraction accuracy. At the heart of language understanding lies one simple question: who did what to whom? So the three main things: the subject, the object, and the verb. Okay. So most of AI models, especially those trained mainly on English and other SVO languages, they learn a quick statistical shortcut. They assume that the word appearing before the verb is the subject. And this trick, it works fine in English, like in our sentence, the user clicks the button, but it falls apart the moment we switch to a language with different word order. Take Japanese, for example. Let's have a sentence which means like the cat chased the dog. For example, in English, it will be translated into the dog chased the cat. The model will understand it by that because it has a different word order. That's not just a small translation slip, it's a complete misunderstanding of the meaning. It will change the whole sentence. So it is a total failure in comprehension. Yeah, and secondly, we have the degradation of generative fluency. When these models try to produce sentences in non-SVO languages, they tend to bleed English patterns into their output. So in Turkish or Japanese, for instance, they might construct a sentence that follows English word order. To a native speaker, that output sounds off. It doesn't sound as a human. It will be clunky and sometimes even grammatically wrong. And that brings us to a deeper point. AI doesn't just need to translate words from one language to another, as we said before. It needs to think to be able to generate the meaning. Okay. So let's look at the morphological complexity. We have a real challenge here. So the languages don't all build meaning the same way. Some use separate words to express ideas, while others pack layers of meanings into a single word. Let's start with analytical languages like English and Chinese. These languages rely on word order, and separate words to convey meaning. Each word usually represents one idea. So in English, the user clicks the button, our example, is clear because the position of each word tells us who's doing what. Next, we have inflectional languages such as Arabic, Latin, and Russian. These languages, they modify the structure of words themselves, changing endings or internal vowels to express grammatical information like tense, case, gender, or a number. For instance, in Arabic, we have the word kitab, which means a book, while kutub means books. It changed the whole word. This small internal change, it carries a grammatical message. So an AI must be able to look at these two different words as the same, but in two different meaning. One is singular, and the other is plural. Yeah, and there's agglutinative languages like Turkish and Finnish and Hungarian. These languages, they take the idea of word formation to the extreme. Yeah, and they glue multiple suffixes, each with its own meaning, into a single root. So the result, it will be an entire sentences can be compressed into one word. So that's a huge change from English. Yeah, okay. There's an example, but I'm unable to read it. Okay, so you get it, I guess. If you have any question, I'll be able to answer it by the end of this session. Okay. Okay, so we have, let's talk about the impact of this evaluation. What happens when we put these languages into an AI models? Let's think about that. Things get complicated very, very quickly. Vocabulary explosion and data sparsity. So in English, the verb write has just a handful of forms. It has writes, wrote, written, and writing. In Spanish, the same verb appears in over 50 forms. In Turkish, a single root can generate thousands of variations. So that means AI training data becomes incredibly sparse. The model might have seen house and at the house in Spanish, but not at my house. So I'm translating the word to English for this one. So to the model, each of these looks like a brand new, unrelated word, but it all have the same meaning, or let's say they all are connected. But to AI, if it doesn't understand what it has in front of it, I mean the data, it won't be able to understand that. It will just not think about it. Okay, for the evaluation, let's talk about the accuracy. When a chatbot faces a barrier or unseen inflected form, it often flags it as out of vocabulary, or simply it fails to recognize it. As a result for that, it can't understand the word, and in many cases, it loses the meaning of the entire sentence. That's why robust evaluation datasets must include rare and complex word forms to truly test how well a model handles real-world linguistics diversity. Okay, and we have failure to generalize. That's a real problem in AI. Okay, so generalization is a true solve for our case here. In theory, a well-trained model should generalize across word patterns. It should recognize that the word at my house and the word at my school in Spanish share the same structure as possessive suffix, followed by the locative suffix. But because of data sparsity, most models they don't see enough examples to learn these rules. They memorize words instead of understanding how they're built. So this is where true linguistic intelligence breaks down. To handle a morphological complexity, AI systems need to move beyond memorization. They must learn to think like a linguist, to see structure and patterns and meaning beneath the surface of words. And that is the let's say the main thing of NLP. And as I said, it's a real let's say pillar, one of the main pillars for large language models to understand linguistic, to be able to generalize and provide and generate text that is correctly grammatically and with the cultural notes. Okay. Let's talk about the lexicyo-cultural challenges when meaning is deeper than words. Okay, so we move from the structure of the language to something even more complex, which is the meaning within the culture. Here, The challenge isn't about grammar or word order. It's about interpretation. It's about how languages carries emotions, also history. So these challenges, they strike directly at the heart of accuracy and comprehension and relevance and in response. Because even if an AI can form a perfect sentence, it can still completely miss what the user really mean. So for the words don't always map neatly across languages. A single word in one language might have several meanings, while another language might not even have a word for the same concept. So that's a huge challenge that the AI has to overcome, or let's say the people behind the AI has to come to solve for that problem. So for example, in German, the word Schadenfreude, I guess that is how it's pronounced, pronunciation, the pronunciation. So it means the joy one feels at another's misfortune. We used here like 5 or 6 words to explain one word in German. There is no single word for that word in English. So that's um, that's a challenge. There are distinct words for snow in some languages, each describing a different texture, shape, or condition. These aren't linguistic quirks. They reflect how people live and what they value. Imagine trying to train an AI model to understand those layers of meaning. That's not just translation, it's cultural translation. You're translating something that cannot even be seen. Okay, 1 second. Give me just 1 second. Okay. I'm sorry for that. Okay. So where were we? Yeah. Let's say a German user asks a chatbot about a company's return policy and uses the word stornieren. In German, this word usually means to cancel, as in canceling a booking or a reservation. But when talking about a physical product, the correct concept is closer to return. So if the AI model translates this word directly into English as cancel, it will misunderstand the user's intent. So the chatbot might respond with instructions on canceling an order before it ships, while the user actually meant returning an item they already received. So what happens here? The response, while grammatically is perfect, it is completely wrong and completely irrelevant. This example shows how fragile meaning can be when language is stripped of its culture context. It's not enough for AI to know the dictionary definition of a word. It has to understand how people use it. So in other meaning, it has to understand this word within its order in the sentence. It has to understand the whole sentence. It has of this word, or even goes ahead and ask it if the AI understand exactly what the if I'm sorry yeah if the AI understand correctly what the user's intent were. So it's a confirmation step to make sure everything is correct and doesn't have a misunderstanding in any way. Because even when two humans are communicating, these misunderstandings mostly they occur and they happen. But here we're talking about chatbots, and those chatbots they are built to be globally. That's for a first, and to give and to receive correct information. So this is a real challenge for AI. It's not as the same as a human person. Okay, I'm going to talk about idioms and figurative speech. So every language is a treasure chest. It is filled with expressions that can't be taken literally. Phrases like to kill two birds with one stone in English, or in Arabic, if we translate it, it means achieving two goals with a single action. But if you translate them word for word, you don't get an idiom or a wisdom. You will only get a violence against birds, right? So, for this challenge, AI models they fall for many traps of idioms and linguistics. And literal translations almost always produces something absurd or completely wrong. If a model doesn't recognize that spill the beans means, which means reveal a secret, it might generate a response about actual beans. So we don't want that. These mistakes are easy to laugh at, but they show something serious, which is a gap between knowing words and understanding the meaning of these words. Okay, so the harder part is when is the when and the how, and is when and how chatbot should use idioms. If it never uses them, it sounds robotic and stiff. I'm sure you all experienced that. But if it uses them too often or in the wrong cultural context, I'm sorry, one second. Okay. So for an idiom like break a leg in English, it means to wish someone luck. It might sound fine in the US, but if you use the same phrase and translated the same words in other languages, it could confuse the person or the user. So the challenge here isn't just recognizing idioms, but knowing when they belong. It's all about understanding and thinking through the words and the sentences. Um, okay, so let's talk about the impact here. When we evaluate a multilingual chatbot, we must test two things: the accuracy and the fluency and relevance. So the accuracy, we have to ask this question: does it correctly understand idioms in user input? For the fluency and the relevance, we have to ask: does it use idiomatic expressions naturally in the right context and with the right tone? So this is the impact here. Okay, let's go to the third, or I'm sorry, to the dialectical variation. Okay, so I just want to say a quick example here. I was working with this customer the other day. We're building this chatbot to be specific for another company, and the chatbot, the person who is testing it, it just sends it laughs at it, like saying ha ha ha. It just sends that, and the chatbot replies with the worst response. It just say something that is provoking, and it's not good. So the customer we're dealing with, the customer that having the company, he didn't like it. So it is hard to build a chatbot to be not as provoking as much, and to be polite, respectful. It's all about the prompt and the data, of course. Okay, so let's go on. Okay, so we will talk about the dialectical variation here, the real language people speak, not just the words. So let's face it, nobody speaks Wikipedia languages, right? Language. People speak the way they live, in a dialect or an accent, or or in a local way. So these varieties, they reflect the community that they live in, and also their history and the identity of each person. So the key point here is that dialects aren't just accents or pronunciation differences, they are complete linguistic systems. So a standard Arabic isn't just as one dialect of Jordan, let's say Arabic, or even Egypt Arabic. So in each of these countries, they have different dialects, so different systems. They have their own vocabulary, their own syntax, and even unique pronouns. So let's think of English as I'm sorry, let's think of language like English. Some people say soda, others say pop, and in some parts of the U.S., like the South, they say Coke, which mean any soft drink. That's not bad grammar. It's cultural and identity embedded in a language. So if we have to look here at the model bias. The language models, they tend to favor the standard or prestigious dialect, the version found in textbooks, news media, and academic writing. That's because this is what dominates the training data. It's all, as I said, it's all about the data. So the result, you have an AI system that performs significantly worse when users speak in non-standard dialects. So we're back to the lab here. The lab is the textbooks, the news media, the Wikipedia. The model is trained in this lab, but outside of it, there is a chaos, a very different languages, dialects, and etc. So let's look at the evaluation here, the accuracy and user satisfaction. So imagine launching a chatbot in English. It might handle standard American English perfectly, but stumble when faced with African American English, or even Indian English, or Singapore English. Studies shown that intent recognition error rates can be dramatically higher for these dialects. So a user saying, "I've been waiting for my refund," might confuse the model completely, even though it's natural sentence for a regular English person. So this doesn't just lead to frustration, it raises serious fairness and ethical concerns. When an entire communities are systematically misunderstood by AI, it's not just a technical issue, it's a social one also. Okay, so the response dilemma. Let's talk about this one. Even when a chatbot does understand a dialect, a tricky question remains: in what language it should respond? Responding in the standard language can feel formal, distant, or maybe condescending. But responding in the dialect, it's risky here. If it's not executed perfectly, it can come off as fake, or maybe mocking the person or the user that is using the chatbot. It will fail an attempt to sound cool. Yeah. Okay. So that's not just awkward, it can seriously damage a brand's image. So people here has to be professional and have a perfect chatbot before launching it to the users. Okay. So let's talk about the relevance and user satisfaction here. User testing, it must be conducted with real speakers from each dialectical community. Some users may prefer a clean and neutral formal tone. Others might connect more deeply with a chatbot that speaks their way. So there's no universal rule here. There is an evaluation that must be qualitative, and it must be qualitative driven by real user feedback, not just metrics, which we covered in the first session when we talked about the evaluation of the chatbot. It must be in two ways: the metric one and the user one. So yeah, let's go for the okay. Let's talk about data-rich versus data-poor languages. Okay, we turn to what is perhaps the single biggest technical challenge in building fair and capable AI systems, which is data scarcity. Modern AI models are data hungry. They don't learn language the way humans do, through interaction or intuition. They learn through exposure by preceding trillions of words. So the more examples they see, the better they get. That's why English, which dominates the internet, as we said before, it looks easy to AI. It's everywhere, in social media, in books, in Wikipedia, in researches, you name it. It's the internet is full with English. But the problem is more than 95% of the world's languages don't have even a fraction of that data. Can you imagine that? So they are what we call low resource languages, meaning that their digital footprint is tiny and often just a few million words or even less than that. This imbalance doesn't just limit access, it shapes who AI understands and who it ignores. Okay, so let's talk on the practical impact on evaluation. Let's look here at how scarcity affects every pillar we use to measure chatbot quality. Let's start with accuracy. Without enough data to train or even fine-tune, the model is simply cannot recognize intent or extract entities correctly. It's like trying to learn French from a single children book. You will never grasp the notes. It will be even mostly impossible. Okay, the second thing is fluency. In low resource languages, models often they generate short, repetitive, and even awkward sentences filled with grammatical mistakes. They sound mechanical because they don't, they haven't seen enough real examples to learn how the people speak and interact. So yeah, this is the fluency. Let's go for the relevance. Maintaining context, knowing what a user is referring to across turns in a conversation is one of the most advanced skills for any model. It's often the first thing to collapse when there isn't enough data. A chatbot might respond fine to one question, then completely lose track of the conversation 2 turns later. So if you try to talk with, let's give an example here. Let's say that you're talking with ChatGPT and you give it structurals as a prompt. Let's say do not answer only answer about myself and do not answer any question beyond that. So the only thing that the AI here knows about is you. For let's say it's just a test. I know that AI do know lots about the data, but right now the prompt says do not reply with anything except about myself. So it will only answer about this specific subject. It will fall short with other and beyond questions from myself. Okay, and the fourth and last pillar is the user satisfaction. For users, the outcome is predictable and disappointing. They walk away from this thinking this technology doesn't work in our language. And the tragic part is they're actually not wrong. The issue isn't their language itself, it's that the language wasn't given enough digital life for AI to learn it properly. I'm gonna give an example here because I'm my native language is Arabic. So in the beginning of the generative era, which was like in 2020, after that. So in the beginning of that, AI weren't as aware of Arabic as it is now. It used to make mistakes all the time. It used to give wrong answers, wrong context. So yeah, I remember that my own let's say feedback wasn't as it is right now. So yeah, it will fall short here as well. Okay, so let's go to the next slide here. Okay. So, oh no, let's start. Let's talk about the translation cascade, the pivot translation cascade. When AI systems don't support a language directly, developers often rely on a common workaround. So it is called a pivot translation approach. Here's how it works. The user message is translated into English, processed by the model, and then translated back into the original language for the response. It sounds clever in theory, but in practice, it creates what we call an error cascade, a chain reaction where small translation makes at mistakes. Mistakes at each step snowball. It makes a snowball reaction into a complete misunderstanding for the sentences. So yeah, let's say a chatbot fails to answer a question in Swahili. The challenge now is figuring out where the failure actually happened. There are 3 possible points to break down: the translation error, also the core comprehension error, the back translation error. So in each one of these, we will have to look for I'm sorry, I got distracted a bit. So yeah, we're talking about the errors here. So the AI or the developers must look into each of these errors to know where the mistake has happened. Okay, let's talk about the evaluation challenge here. Imagine trying to evaluate all this to figure out where the error occurred. You need an expert human to that is fluent in both languages. Plus, he is or she is specialist in tools to inspect every step. So, like the input and the intermediate English version and the final output. This mistake, it's the evaluation process exponentially is more complex and expensive, and worse to be and to talk worse about this, it blurs accountably. So when a response goes wrong, who's to blame? The translator, the model, or the system design itself? It's a real complex and challenge to fix over here. Okay. Let's take like 3 to 5 minutes break, and we will continue. We only have like 3 more slides to finish over here. Yeah. So yeah, let's just take 5 minutes. Okay. So I just let's get back. Okay. So let's do a quick recap, or let's say a quick sum up of this. Okay. We will talk here about the cultural norms, the invisible rule of communication. Culture doesn't just influence what we say, it also shapes how we say it. And when we say something, it's a different thing from what AI could understand. These are the invisible rules that govern human communication, and they are every bit of as important as grammar or vocabulary. So what's appropriate or polite or clear, it varies dramatically from one culture to another. And for AI systems that interact with humans, this is one of the hardest frontiers to cross. Okay, let's talk about high context versus low context communication. Linguists often describe cultures along a spectrum from low context to high context communication styles. In low context cultures like Germany or North America, people tend to say exactly what they mean. Messages are explicit, they are direct and self-contained. Clarity here is a virtue. In high context cultures, such as Japan or the Middle East, much of the meaning lies between the lines. And also the tone, the body language, and the relationship dynamics, they all carry as much weight as the cultural words. The listener is expected to read the air, not just the sentence. So for humans, this subtle dance is natural. For chatbots, it's minefield. Let's look at a real example. In Japanese, a user interacts with a customer service chatbot. Instead of saying this product is broken, I want a refund, they might say a sentence, which means it seems there is a small problem. To a Western trained chatbot, this sounds like mild feedback, maybe a low priority, like thank you for your comment situation. But in Japanese culture, this is a highly polite way of lodging a serious complaint. If the chatbot fails to understand that nuance and replies with something like, thank you for your feedback, the user won't feel acknowledged at all. They will feel dismissed. What started as a polite message suddenly becomes a moment of frustration and offense, like the situation that I had with the customer. So why this matters for evaluation? This is not just translation. We've been saying this from the beginning. It's not just a translation issue. It is a cultural comprehension issue. When evaluating chatbots, we need to go beyond literal intent detection and look for implicit intent. That means testing whether the model understands indirect speech, politeness, and strategies, also cultural cues that carry meanings beyond words. Otherwise, even the most advanced chatbot can fail the simplest human test, which is understanding what someone really means, the intent behind the sentence. So to adapt with the user satisfaction metrics, even our evaluation metrics like CSAT, the customer satisfaction score, aren't immune to cultural biases. At first glance, this metric seems objective. You ask users to rate their experience on a scale from 1 to 5, then it calculates the average. It's simple, right? But in reality, cultural habits, they deeply influence how people use those numbers. So let's say in some cultures, people naturally avoid extreme ratings. They tend to stay in the middle of the scale, giving a 3s and 4s rather than 1s and 5s, because being too positive or too negative feels inappropriate. In other cultures, especially where direct feedback is encouraged, users are much more comfortable giving strong opinions, high praise, or clear criticism. For example, Japanese users might rate a chatbot interaction at 3.5, while American users might rate the exact same experience at 4.5. The difference doesn't reflect quality, it reflects culture over here. So in Japan, moderation is polite. In the US, directness is valued. So if we simply compare these numbers at face value, we would mistakenly think the system performs worse in Japan when it actually doesn't. So uh, the reliability of a metric, this here creates a major challenge for evaluation teams. Raw CSAT scores cannot be compared across cultures. They need to be calibrated, adjusted based on a local response tendencies. Alternatively, evaluators can rely more heavily on implicit behavioral metrics like task completion rate or conversation dropout rate. These metrics reflect real behavior, whether the user actually got what they needed without being filtered through cultural norms about politeness or criticism. So yeah. Okay, let's go for the. Okay. We skipped. We didn't skip this one. I actually did. Um, I actually did it, but let's go for the last slide here, the conclusion. Okay. So let's wrap things up. In this session, we have taken a deep and honest look at what it truly means to evaluate chatbots in a global context. We have seen that this challenge is far from complex than simple translation. It reaches into the very structure of languages, the diversity of dialects, and the subtitles of cultural norms and the digital divide that separates data-rich and data-poor languages. We also learned that each of the four pillars of quality, the accuracy, the fluency, the relevance, and user satisfaction, they must be redefined through this lens of global diversity. Because what counts as accurate in one culture may sound tone deaf in another, and what feels fluent to one user might or may feel artificial to someone else. Building a global chatbot is not just a technical mission right here, it's an ethical responsibility. It requires us to confront our own biases, to question what our model are learning, and to ensure that our technologies are serve all linguistic communities, not just the ones that with most of the data. This deeper understanding make us better evaluators and better designers, better thinkers. It teaches us to approach every data set, every metric, and every model with healthy skepticism. Refusing quick fixes and shallow claims of universal intelligence, and that's in quote unquote universal. So now, equipped with this awareness, we are ready to take the next step. In our upcoming session, we will move from general linguistic challenges to specialized and high-stakes domains, fields where precision isn't optional and the margin for errors is effectively zero. Okay. So yeah, that's for the next session. Thank you so much over here for this one. Okay. We have finished here. Everyone who wants to... Thank you.